Hi guys, welcome to Easy Math.
In this video, we are going to find the inverse. Let us see what is the formula for finding the inverse. For example, if it is A inverse means the formula for finding inverse is 1 by determinant of A into adjoint A. Okay, we know how to find adjoint A. We know how to find the determinant of A. With these two things we can find the A inverse. And in the question it is also mentioned if it exists. Only we have to find the inverse. What does this mean if it exists? That I will tell you while solving the problem. Okay, we will start off with the first problem. The first matrix I will consider it as the matrix A. Okay, minus 2, 4, 1, minus 3. We have considered this matrix as A, and we know the formula for inverse is 1 by determinant of A into adjoint A. First let us find determinant A. How to find determinant A for 2 cross 2 matrix means first we have to multiply this diagonal wise. That is minus 3 into minus 2 will become plus 6. This side obviously will have one default minus. 4 into 1 is 4. 6 minus 4 is nothing but 2. If this value, if it is not equals to 0, then we can find the inverse. If this value, if it is equals to 0, that is determinant value, if it is not equals to 0, we can find the inverse. We can find inverse. That is inverse exist. We can find inverse, or we can say it as inverse exist. Okay. Now, we will find the adjoint A for this 2 cross 2 matrix. Adjoint A equals to, we know how to find the adjoint A. This diagonal wise we have to swap the elements. Minus 3, minus 2. This diagonal wise we have to change the symbol. That is minus 4, minus 1. Next we will substitute in the formula A inverse. Okay. What is the formula? A inverse equals to 1 by determinant A into adjoint A. 1 by, what is the value of determinant A we got for this problem is 2. Adjoint A we got is minus 3, minus 4, minus 1, minus 2. This is the inverse of A for this problem. Now we are going to find the inverse for the second subdivision. Second subdivision, I will consider the matrix as A matrix. Okay. What's the question given? 5, 1, 1, 1, 5, 1, 1, 1, 5. Okay. First, always while finding the inverse, we will find the determinant value. If it is not equals to 0 only, we can find the inverse. Only after finding the determinant of A and not equals to 0, we can go for adjoint of A. Okay. How to find the determinant of A when it comes to 3 cross 3 matrix means, we can consider either row wise or we can consider column wise. Now we will consider row wise. Okay, considering 5, we have to omit the column which is touching this 5. We have to omit the row which is touching this 5. So, we will get this matrix 5 5s are 25 minus 1. Okay, this term will have one default minus. Minus 1 into, we have to omit the column which is touching this 1. We have to omit the row which is touching this 1. So, we will get this term, that is 5 into 1 is 5 minus 1. Plus 1 into, we have to omit this column and this row. 1 minus 5. We will simplify 5 into 25 minus 1, it is 24. Minus 1 into 5 minus 1 is 4. Plus 1 into 1 minus 5 is minus 4. 24 into 5 is 120. Minus 4, minus 4. Minus 4 minus 4 is minus 8. 120 minus 8 is 112. Obviously, this value of determinant A 112 is not equals to 0. Therefore, inverse exists. Therefore, inverse exists. Now, we have to find the adjoint of A. Adjoint of A equals to, we already know, we saw how to find the adjoint of A. Okay. We have to write the minor for all the terms. Okay. For first term 5, it is 5, 1, 1, 5. Alternative term will have minus, and we considering this 1, we will get 1, 1, 1, 5. And for the third term we have to write the minor, which is nothing but this row will be omitted, this column will be omitted. 1, 5, 1, 1. Next term will have minus by default. For this one term, we have to omit this row and this column, which is 1, 1, 1, 5. Next term, for 5 it is, the minor is, we have to omit this row and this column, 5, 1, 1, 5. Alternative term minus. Next we have to omit this row and this column. It is 5, 1, 1, 1. Next term, we have to omit this row and this column. It is 1, 1, 5, 1. Next term will have default minus. The omit this row and this column. It is 5, 1, 1, 1. And for the last term it is, we have to omit this row and this column. It is 5, 1, 1, 5. Now we will simplify this. We have to take the transpose as well. Minus 1. Minus we will have it outside. 5 minus 1. 1 minus 5. Next is minus we will have it outside. 5 minus 1. 25 minus 1. Next minus we will have it outside. 5 minus 1. Next 1 minus 5 minus 5 minus 1. 25 minus 1. At last we have to take the transpose. Next we will simplify. 25 minus 1 is 24. 5 minus 1 is 4 minus 4. Minus 4. 5 minus 1 is 4 minus 4. 24 minus 4 minus 4 minus 4. 24. And we have to take the transpose. Transpose means row wise we have to write it as column wise. First row I am writing it as first column. 24 minus 4 minus 4. Second row I am writing it as second column. Minus 4, 24 minus 4. Third row I am writing it as third column. Minus 4 minus 4, 24. So this is adjoint of A. A inverse equals to, determinant A we got is 112 and adjoint of A is nothing but 24 minus 4 minus 4 minus 4 24 minus 4 minus 4 minus 4 24. So within the matrix all the terms are multiples of 4, so we can take it 4 common. 1 by 112, that is I am taking 4 common. It would become 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6, and we can cancel these terms. 1 by 28. So this is the inverse for this. Third subdivision we will consider the matrix as A. Question is 2, 3, 1, 3, 4, 1, 3, 7, 2. Obviously while finding the inverse, first we have to find the determinant of A. How to find the determinant of A? So determinant A equals to, either we have to find row wise or column wise. I will always find row wise. 2 into, we have to eliminate the column which is touching that element and eliminate the row which is touching that element. The submatrix would be this. We have to multiply 4 2s are 8 minus 7. By default we will have one minus 3 into 6 minus 3 plus 1 into 21 minus 12. 2 into 8 minus 7 it is 1, minus 3 into 6 minus 3 it is 3, plus 1 into 21 minus 12 it is 9. 2 minus 9 plus 9, minus 9 plus 9 will get cancelled. Determinant of A which is equals to 2. Obviously this is not equals to 0. Therefore inverse exists. Next we have to find the value of adjoint A. For finding the adjoint A we have to write the minus of all the elements and finally we have to take the transpose. I will write the minus for the first term. It would be 4, 1, 7, 2. By default we will have one minus for the second term. The minus would be 3, 1, 3, 2. And the minor for the third term is 3, 4, 3, 7. By default we will have one minus. Next it is 3, 1, 7, 2. And the next term is 2, 1, 3, 2. By default we will have one minus. Next term is 2, 3, 3, 7. And the minor for the next term is 3, 1, 4, 1. Minor for the next term is 2, 1, 3, 1. And minor for the next term is 2, 3, 3, 4. We have to simplify this and take a transpose finally to find the adjoint of A, which is equals to 8 minus 7 minus 6 minus 3, 21 minus 12. Next is minus of 6 minus 7, 4 minus 3, minus of 14 minus 9, 3 minus 4, minus of 2 minus 3, next is 8 minus 9, and we have to take the transpose finally. So if I simplify, 8 minus 7 it is 1, 6 minus 3 it is minus 3, 1 minus 12 it is 9, 6 minus 7 minus 1 it will become plus 1, 4 minus 3 it is 1, 14 minus 9 it is minus 5, minus 1 it will become plus 1, minus 1, and we have to take the transpose. Adjoint A equals to 1 minus 3, 9. Transpose means row element we have to write it in column wise. Second row will become second column, 1, 1, minus 5. Third row will become third column, minus 1, 1, minus 1. So thus we have found the value of adjoint A. So let us substitute in the formula. A inverse equals to 1 by determinant of A into adjoint A. We have found both determinant A value and adjoint A value. Determinant A value is 2 and adjoint A is 1, 1, minus 1, minus 3, 1, 1, 9, minus 5, minus 1. This is the value of A inverse for this problem.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.